Hello, everyone. My name is Ankit Kapoor. I'm part of the AI product management team at Qualcomm.
Hi, I'm Manuj. I lead the overall Windows AI infrastructure at Qualcomm.
Thank you for coming. And so, in today's session, we are going to cover some of the top generative AI trends on the edge devices. Along with that, it'll be Qualcomm's generative AI stack. And Manuj is going to show how you can leverage the Copilot features on the Snapdragon's X-Elite NPU, along with creation of agentic AI workflows, and followed by a demo. All right. Um, Qualcomm has been developing platforms and the supporting SDKs for AI models to run locally on the NPU for over a decade now. Uh, Initially, the platforms were created to run perceptive AI-based use cases. About 3 years ago, the trend of generative AI started, where you would enable use cases like chatbots running locally on your NPU. And as you heard in the keynote today morning, it was all about agentic AI. Now, agentic AI, what does it mean? It means that it allows multiple large language models, small language models, and web services to communicate with each other and service a particular user's query, right? Um, with the advancement in the Gen AI research, we are now able to create SLMs, which are like small language models, maybe 13 billion parameter or smaller, to run locally on the NPU and give you quite accurate results comparable to like large language models from a year ago or so. So running these SLMs locally on your edge opens up endless opportunities for you to develop your use cases and run locally on the NPU. So in the agentic AI trend, to run multiple SLMs on the resource-constrained edge devices, Qualcomm is partnering with Microsoft and a few others to create new and updated quantization techniques so that, for example, taking a model from 4-bit data type down to sub 2-bit data types, so that they can all fit on your edge devices and you can run multiple of those models. Moving to the edge also enables you to provide your models with more contextual information, which is more personal to a device. Um, and you could also take data from devices' sensors and provide it to the model, so you get more personal response back to the user. Um, so, and with this, it leads us to the fourth and the very important trend, which is responsible AI. Here, you have to protect the PII of a user onto the device. So Qualcomm is heavily invested in these trends, and we are enabling our developer community through various partnerships and tool chains. Let's look at the Qualcomm's generative AI stack. Traditionally, the generative AI stacks leverage NPU via a proprietary software stack from a particular vendor. In Qualcomm's generative AI stack, we have closely integrated with industry standard Orchestrator and different AI frameworks. Orchestrator layer basically helps develop agentic AI use cases. Qualcomm has its own offering of the Orchestrator SDK. We have also worked closely with Microsoft to enable users and applications to access the Copilot models that run locally on your NPU. Later in the session, Manuj will cover and show you how we also utilize industry standard AI Foundry, which was announced again in the keynote today. And for example, how do you use a semantic kernels to run your orchestration framework locally onto the device? Um, and in the AI framework layer, we have our own proprietary AI engine runtime SDK, which is highly optimized to run your AI models onto the NPU. We have also announced today at the keynote that we are integrating the AI Foundry, Windows AI Foundry, and also we work quite well with the Onyx Runtime Gen AI SDKs.
Okay, thanks, Ankit. So as you can see, what we are planning at Qualcomm is to provide multiple pathways to enable bringing AI models to the edge, right? So it's not single way. We got your feedback. We want to use industry standard APIs also working as a backend on Qualcomm AI SDK to enable these models, new next generation AI models on the edge devices. So here in the next section, I will go over two case studies. One is using Microsoft Copilot models, and the other one is using the industry standard AI Foundry or semantic kernels, how you can leverage semantic kernels, next APIs, and connect with our AI frameworks, including the Windows AI Foundry to develop a next generation or models on use cases on the edge devices. So I'll start with Copilot features. Now, this AI Dev Gallery, if you must have seen last year at Ignite, Microsoft launched AI Dev Gallery. It's also part of Windows SDK. You can use the same samples. The goal of this AI Dev Gallery is Microsoft wants to provide models which are inbuilt in the OS, or it has already been optimized for the NPU, CPU, GPU platforms. What at Qualcomm we have done collaborating with Microsoft is to optimize these models for best running on our NPU, power efficient. So you don't, as a developer, need to worry about quantization, taking which framework tool needs to be used. All of them is already predefined, and the time you can spend is integrating those models which are already optimized in your application. So we'll take one case study from this AI Dev Gallery is using Silica. You must have heard in morning's keynote from Satya, Silica is an optimized model. It has now reasoning, multi-model, got updated this April. These models have been optimized for power efficiency, especially on the local device. As we know, the resource constraint is there, memory constraint is there. These are all optimized at the lower bit by collaborating with Microsoft research team, right? So now with this new model, what they have done is this is the AI Dev Gallery. You can see on the left-hand side, we are using paraphrase text, and it was running on the NPU, but also in the latest update, they have added LoRa or fine tuning. Again, these are all set of high-level APIs, all accessible through Windows SDK, which you can use through the inbox OS, right? So the new use cases like custom parameters, content moderation, these are the new models or extension which have been added to Silica model. Now, this is one way of leveraging inbox models. So you, again, as a developer, you will not spend time on finding which model you need to go explore for your own local edge devices. Next, we want to extend that to Agentic AI. Now, Agentic AI on Qualcomm, we are leading on bringing new use cases on the local edge devices, right? So the goal here is, because its data is local, we want to provide that personalized context understanding using, again, the stack which is already behind is Qualcomm AI Runtime. But we want to extend that with the industry standard APIs like ONNX Runtime GenAI, semantic kernels, and the Foundry local, which was launched today. So what we are trying to do is using the current stack on the local where you have a lot of human input, we want to personalize that. We add with the next generation Qualcomm AI orchestration, which provides us the best facility using our SDK stack, and then add to the LLMs, LVM, or LM multi-model use cases. So you can run on our NPU, CPU, and GPU. So again, what we are trying to do is the next generation use case. If you are developing for cloud, you're already using these APIs using OpenAI or any other standard API use cases. You can connect with the ORT GenAI, and on the lower level, it will use our QNN SDK stack, and you can bring those models back to client. Now, these are not, again, experimental. Lot of real world use cases like recall, graph APIs, or podcast generation. Already these use cases are deployed in the OS. One example is graph APIs, Microsoft Graph, or any other vendor graph. You can connect with this third-party application to leverage this agentic, and it can run on the edge device. What we will go over is how you can build this agent using that flow which we went over. So what we are trying to do here is we want to create a chat application, and the agent is an admin. So it will go through the message history and look into using all the message stuff happen. Here we'll use Discord as one example, but you can expand to any other third-party use case using the Graph API. And we want to create a background service of agentic app service. Now, we are using semantic kernels, and these semantic kernels now can be connected with ONNX runtime Gen AI, and that behind the scene runs using Qualcomm AI runtime SDK. Now, we are right now using SLM model, but you can bring any of the 1,000+ models of LLMs, which was shared in the part of the Foundry, which runs locally on our edge platform using AI, Microsoft Windows ML Foundry. So now let's connect those stuff and build a service. So first thing is we want to define AI model using ORT Gen AI. As I said, it's already predefined models are available part of the Foundry, and it runs on our Hexagon NPU. Next, we integrate the semantic kernel, and these are the industry standard API which you will be using either with OpenAI or on the ORT runtime Gen AI or any other third-party application like Ollama, which also supports semantic kernels. Next, we build the agent, and the goal of the agent is it's an admin. It looks at the history and figure out what next needs to be done. Like here, it will be a scheduling stuff. We add the orchestration, and the goal of orchestration is guardrails. So a message will come, do you want to set up the meeting schedule or not? And then we deploy. So on the left-hand side, you can see the code for integrating semantic kernel and connecting with the ORT Gen AI API. So it's a very simple, you have a semantic kernel, you connect with the ORT, and on the backend, you can use our device NPU. It will use the ORT QNN backend, and it will run on our NPU side. So if the model is supported, which is part of those AI Foundry models, it will run on our NPU side. On the right-hand side, you can see we create a agent which will go through the history of the chat and do schedule. It will work as an admin to schedule the work based on your left hand, and all of this stuff runs on device and on low power because the model is already optimized with the lower precision. Now, with that, we want to show.
Yeah.
Okay. So, which screen it is right now?
Yeah, this is
No, but it's not being seen now.
Oh.
Okay, wait. Okay, yes,
Yeah,
it's up. So here is a chat application, and there's a back chat going on the agentic here we created using the semantic kernel and ORT. This is a Discord-based application, and what we do is we created a bot which is running on the background using the ORT Gen AI framework with semantic kernel, and we say set the meeting, and with this, what it will happen is it will go through all the context use cases, and we have a service which is running on the background. It can be a Discord based because this is an agent, but as I said, you can create multiple agent users semantic, and all are running locally on our NPU. And what it happens is it processes every of the context, all the messages in the history, and we have requested, please set up the bot, work as an admin, please set up the meeting invite based on the schedule of all the chat messages, right? And with that, you can see the bot goes back and says, okay, detail has been sent, and this is a guardrail we want to create. The message comes now, if you want to accept and all, it's up to the user what next it has to be done. Again, this all stuff is running locally using the standard API stack and goes to the our NPU stuff. Now with that, I'll give back to Ankit on.
Thanks, Manuj.
Demo one.
All right. All right. I know this information could be overwhelming for all of you. So for what we have done is we to help our developer community, we have created a bunch of resources. If you're developing a Gen AI based use case, we provide you with Jupyter notebooks, C++ sample code, and some white papers. It makes your life easy in converting the models because you have to go through a quantization phase and deployment phase. We also have a resource for you, which is called a Qualcomm AI Hub, which provides you access to different Qualcomm Snapdragon-based devices, different form factors, so that you can test your use cases across all of them, like XR, VR, IoT, automotive, etc. And we also contribute heavily to the GitHub. And you can see some of the projects we have posted in source code, and you can take that info. So with that, thank you for attending this session. Please stop by at the Qualcomm booth right there to see some of the Gen AI demos. We also have a party scheduled. You can inquire about it at the booth also. And yeah, thank you, everyone.
Thank you.
Oh, and we do also have a workshop for you.